Hi everyone, I hope you're okay, and I really hope that guys the videos I keep uploading are helping you out. Please note that this is video number 2, which simply means I'm doing question 2 from the grade 11 mathematics paper 1 examination, which was written in the year 2022. This question paper was issued by the Department of Basic Education. Please note that there's already one video being uploaded, and there are 7 videos that will be uploaded after this one, which simply means that each question will have its own video. You can just click the link on the description below. It will direct you straight to the playlist with the full memorandum. You can download the question paper, answer the questions with me. If there are things you're not sure about, please do ask on the comment section. I'll definitely come and assist you. And please guys, don't forget to share to your peers, like the content and subscribe. And sharing to your peers guys is important, because you'll never know whether whatever that you are saying here it can help them to commit lesser mistakes while they are doing or rather while they are writing their final examination. Okay, so the first question simply says that I have 2 to the power 2n plus 2 multiplied by 4 to the n plus 1 all over 8 to the power n minus 1, right? So since I don't have plus and minuses separating my terms, the only thing I need to do is to make sure that I have the same base. Okay, so this is equal to 2 to the power n plus 2 multiplied by 4. I know that 4 can be written as 2 squared, so I'll just substitute 4 and write 2 squared, and then I still have the exponent, and I have 8 as well. 8 can be written as 2 to the power 3. Remember that I still have the exponent n minus 1. So now all I need to do is to remove the brackets, right? So I simply have 2 to the power n plus 2 multiplied by 2 to the power 2n plus 2. Remember that powers and exponents, they always multiply one another, right? And then at the denominator, we'll simply have 2 to the power 3n minus 3, right? Okay, since at the top everything is multiplying, I'll simply take one base and then add my exponents. I'll have n plus 2 plus 2n plus 2, right? And then this term here at the denominator is just dividing everything which is at the top, so I'll just subtract its exponent. I'll say negative 3n minus 3. So now I'll simply have 2 to the power 3n plus 4 minus 3 to the n plus 3. Are we together? So I know that the 3n's will subtract one another, and I'll end up having 2 to the power 7, which will give me 128. So this is equal to 128. Okay, now let's go and do 2.1.2. 2.1.2. I have 2 terms being multiplied, right? There's a rule that guys that simply says that if ever you have the square root of a multiplied by the square root of b, you can simply write this as the square root of a multiplied by b, right? So this means I can simply change this thing and write it under one root. So I can simply write it as the square root of x plus the square root of 2x plus 2x minus 1 multiplied by x minus the square root of 2x minus 1, like this, né? Okay, if you can check guys, this is just a factorized version of difference of 2 squares together. But if you cannot see that, you can just multiply. You can just do the FOIL method, né? You can just do the FOIL method, and you will end up having x squared minus the square root of 2x minus 1 all squared. together, and then this will obviously give you x squared minus 2x minus 1, and you'll have x squared minus 2x plus 1. This thing is factorizable. It's x minus 1 and x minus 1, right? Which can be written as x minus 1 all squared, and this is equal to just x minus 1. So I now know that whenever I simplify this, it will be simplified to be x minus 1. Okay, now let's move to 2.2. Let's move to 2.2. 2.2, I'm given a p, né? And then I'm being asked, for which values of x will p be a real number? P will be a real number if and only if whatever that is under the square root 5 over x plus 2 is greater or equal to 0. Are you together? It simply means I'm just dividing two terms and my answer is greater than 0. That means the two terms that I'm dividing must have the same sign. If they must be either both negative or both positive. I have a 5 there. Are you together? So for me to divide a 5 with another number and find an answer which is positive, that means this other number has to be positive as well. So this simply means that x plus 2 must be greater than 0. Please note I cannot say greater or equal to 0. Why? Because x plus 2 is at the denominator. I cannot have my denominator to be equal to 0. Because once I have my denominator to be equal to 0, the entire number will be undefined. So for this thing to be real, x must be greater than or negative 2. X must be greater than negative 2. Okay, then I'm supposed to show that p is rational if x is equal to 3. Basically, they just want me to substitute 3 in space of x. P is equal to the square root of 5 all over x plus 2 plus x all over 3. Whenever I come across x, I just need to substitute 3. If I get an answer which has a square root, that means p is irrational. But if I get an answer that doesn't have a square root, it simply means that p is rational. So I'll simply have the square root of 5 over 5 plus 1. 3 over 3 is just 1, right? So I'll have 1 plus 1, which is 2. So p is equal to 2, and 2 is a rational number. Together. So now I've shown that p will be equal to a rational number when x is 3. Are you together? So when x is 3, therefore p is equal to 2, which is a rational number. Okay, and then now at 2.3, I'm supposed to calculate the sum of the digits of this product. Are you together? So all of the time, guys, once you deal with exponents, with numbers with huge exponents, the catch here, guys, is to just change your exponents to look the same. You have 2 to the power 20 15 multiplied by 5 to the power 20 19, right? So 2 to the power 20 15 multiplied by 5 to the power 20 15 plus 4. We must always try to change our largest exponent to look like the smallest exponent. Okay, this is 2 to the power 20 15 multiplied by 5 to the power 20 15 multiplied by 5 to the power 4. All together, 5 to the power 4, I know that it will give me 625. This is multiplied by 2 to the power 20 15, and then multiplied by 5 to the power 20 15, right? There's a rule that simply says that if you have 2 to the x multiply, let me use unknowns. If we have a to the x and b to the x, you can simply write this thing as a times b all raised to the power of x. All right, together. There's an exponential law which states that. So I have 625, and what's inside the bracket can be written as 2 times 10. Ha ha ha. Doesn't trend. 2 times 5 all raised to the power 2015. So this is just 625 multiplied by 10 to the power 2015. So 625 times 10 to the 2015. This thing simply means that, guys, I have 625 and then I have 2015 zeros after these numbers. All right, together. So I'll just have multiple zeros, which are 2015. So whenever I want to find the sum of my digits, I'll just say 6 plus 2 plus 5 plus the zeros. Whenever you add a zero to a number, there's nothing you're changing. So therefore the sum of the digits is just 6 plus 2 is 8 plus 5, that's 13. The sum of these digits, the sum of the digits of this product is just 13. All right, together. Let me write in red. How am I? I said red. Sum of digits is equal to 13. That's how guys we're supposed to tackle the second question. I hope, guys, the video helped you out. Please stay tuned and wait for more videos. Thank you.